house is not empty today, and you better listen to the words I say. We are talking mathematics and the long journey of solving quadratic equations by using factoring and by using the quadratic formula is over. This is part 4. It is the last installment. So, we're going to take it out with a bang with an excellent word problem. This is the only example. Are we ready? I know you are. We are back and better than ever. Okay, so Diane Cicero and her husband recently installed an in-ground rectangular swimming pool measuring 40 feet by 30 feet. So the first thing we are going to do, boys and girls, is we are going to draw a swimming pool. How about that? So here's the swimming pool, rectangular, and just for kicks, let's put some water in it. Oh, didn't mean to do that. Just for kicks, let's put some water in it. Bam, okay, I feel better. All right, so we got that, and we also know, let's put down the information, that it measures 30 feet by 40 feet. So I'm going to put a 30 and 40 there. I'll put one here too, just for kicks. And this is 30 because it's a rectangle, right? Okay, so we're good. They want to add a brick border of uniform, that means the same, width around all the sides of the pool. Okay, so now we need a uniform doohickey around the sides of the pool. So let's see, let's go back to here and let's see if we do this. Okay, it's going to cover up the pool, no need to panic, I'm going to take care of that. Watch Mr. B. We're going to order, we're going to send to the back, life is good. Okay, so we now have our sidewalk around the pool and we're just going to pretend there, that's about right, that it's a uniform width. In other words, it's the same width sidewalk all the way around. Okay. How wide can they make the brick border if they purchase enough brick to cover an area of 296 square feet? So this is going to take a lot of thought here. Okay. If you don't know where to start, how wide can they make the brick border? So they're asking, how wide is it from here to here? And when you don't know what to do with a word problem, let the variable represent what it is you're being asked to find. So I'm going to let x represent the width of the sidewalk. Okay, and that's this white thing around here. It's going to be a white sidewalk, so there. Okay, and so since it's the same width all the way around, this is x as well, this is x as well, and this is x too. Okay, so it's all x all the way around. What else do we know? The brick is going to be 296 square feet. So all this stuff in here, all the brick, pretend that's brick. Just humor me, okay? So all of this is brick. This area, the surface area of the brick has to be 296, okay? How wide can they make the brick water if purchase enough brick to carry an area of 296 feet? Okay. Well, let's think about this right here. The area of the brick, if you think about it, is equal to the area of the big rectangle minus the area of the pool. Okay, so if you think about, if I took this rectangle, I'm just going to move it out of the way. If I took the area of this entire rectangle, right, just think of that entire rectangle right there. Now I'm going to put it back, and I subtract the area of the pool, I'm left with the area of the brick. And the good news is we know the area of the pool, or we can figure it out because we know the dimensions. 30 times 40, that is going to be a pool area. Oops, I don't have the pen, so let me turn it to pen. The area of the pool is 1,200 square feet because 40 times 30 is 1,200. Okay, so we know some things here, right? The area of the brick, we need it to be 296. Okay, and that has to equal the area of the big rectangle, we'll get to that in a second, minus the area of the pool. So it's going to be minus 1200. Okay, so we're getting somewhere. Well, the area of the big rectangle is the length multiplied by the width. Well, what is the length? The length goes from here to here. Well, I know from here to here is 40, right? So what about all the way across here, right? From here all the way to here is this 40 plus the 2x's. So the length equals 40 plus 2x. Okay. And the width, the same thing. I know that from here to here is 30, so if I go all the way along here, from here to here is this 30 plus x, well that's plus 2x. So the width is 30 plus 2x. So the area of the rectangle is equal to length times width, or 40 plus 2x multiplied by 30 plus 2x. And since we let x represent the width of the sidewalk, if we solve for x, we are in business. Okay. Well, the first thing I'm going to do is subtract 296 from both sides, minus 296. Okay. And now I have 0. Here, let me put a line here just so we don't get it confused. Okay. 0 is equal to 40 plus 2x times 30 plus 2x minus 1496, right? Negative 1200 and negative 296. Okay. So I'm going to FOIL this, and I have 0 equals 40 times 30 is 1200. 40 times 2x is 80x. 2x times 30 is 60x. And 2x times 2x is 4x squared. Minus 1496. Boy, I did something stupid. Because had I just left it alone, look, I would have had this 1200 minus this 1200, and we just have the 296. So sorry about that, not a big deal. So now what do I have left? I have, I'm going to start with my greatest exponent. I have 4x squared. Then I'm going to put my x's. 80x plus 60x is 140x. And then we just talked about this. This is going to be minus 296, which is 1200 minus 1496. Okay, so, oh, I have a quadratic. So I'm going to try and solve it by factoring. So 0 equals 4 times x squared. Let's see, 140 divided by 4 is 35. So that's plus 35x. And then we know that 296 is divisible by 4 because 300 is divisible by 4, and 296 is 4 less than it. So that is going to be minus 74. You'd have to figure that out on the side there. Okay, then I'm going to divide both sides by 4, right? Kapow, that cancels out. Okay, so now I have to move up here, right up here. 0 divided by 4 is 0. And that's going to equal x squared plus 35x minus 74. Okay, so now I need factors of 74 of negative 74 that combine to give me a positive 35. Okay, so x is going to go here, x is going to go here. We know it's not going to be 74 and 1 because there's no way that a combination of 74 and 1 are going to give me 35. Okay, so maybe I do some work down here. What about 74 divided by 2? That is 37. So if I did a positive 2 times a negative 37, That gives me the 74, and if I combine those, that's what? Negative 35. Close, I need positive, so all I need to do is make the 2 negative times a positive 37. That's still negative 74, and that combines to give me the positive 35 I need. So this becomes x minus 2 times x plus 37. Okay. Now I need to solve that, so I can say that x minus 2 equals 0, or x plus 37 equals 0. And we solve here, plus 2, so we get, this is making me nervous, I don't want you to get it confused, so I'm going to draw a little box here. So x equals 2, or, what do we get here? Minus 37. So I get, or x equals negative 37, right? So these are my two possible solutions, but we're going to throw out the negative one. And why are we going to throw out the negative one? Well, you can't have a negative length, can you? Can't do it. So for this particular situation, this answer doesn't make sense, and our good answer is x equals 2. So how wide can they make the brick border? That would be, and I ran out of the room, 2 feet wide. And there you have it. We will see you next time. Becker is out!